We were discussing the translation argument in favor of realism about abstract universals. According to the translation argument, there are apparent truths about abstract universals, abstract entities like virtues, shapes, and so forth. The translation argument in favor of realism about such abstract universals claims that there are truths about abstract universals, for example, truths about shapes, that cannot be translated into equivalent statements that are wholly or entirely about concrete particulars. We went over a number of examples of apparent truths about abstract universals, and we were assessing whether we could come up with translations of these truths into statements that are wholly about concrete particulars. The last example that we had was the apparent truth that there are shapes that are never exemplified. So there are clearly some shapes that are exemplified. On the other hand, there appear to be many others, and definitely many other shapes that never have any concrete instances. You might consider some very complex shape, say a shape that can only be exemplified by an object if that object has 10 to the 10 to the 100th power of size. Such an object might be called a Google plexagon. A Google is 10 to the 100th power, and 10 to the Google is called a Googleplex, a very, very large number. So large, in fact, that it far exceeds the total number of particles in the observable universe, at least as far as our current scientific theory maintains. So it's clear that that shape, although mathematically just as legitimate as any other shape, would never have any instances in the world. There would be nothing, in other words, that exemplified that shape, because there simply aren't enough objects in the universe to make an object that has that vast number of sides. So it appears very plausible indeed that there are shapes that are never exemplified. Can the nominalist find a way to express this truth without referring to shapes? To do that, the nominalist would have to find a way to capture this truth in terms of references to either shaped objects or references to particular sorts of shaped objects. For example, triangular objects, square objects, pentagonal objects, and so on. Now, if we talk about shaped objects, we might say that the original statement can be translated by saying that some shaped objects never exist. But if you think about that statement, you'll see that can't be an adequate translation. The problem is that the translation is an impossible statement. It's not possible that there are some shaped objects that never exist. If there are these shaped objects, then clearly it's the case that they do exist, and it can't be the case that they never exist. So the proposed translation of there are shapes that are never exemplified as some shaped objects never exist will fail. The proposed translation that some shaped objects never exist is an impossible statement, so its truth value is that of being necessarily false, whereas a statement we're trying to translate, that there are shapes that are never exemplified, is true, so evidently they're not equivalent. Perhaps, though, we could translate the statement that there are some shapes that are never exemplified by talking about the non-existence of particular sorts of shaped objects. For example, it might be proposed that there are shapes that are never exemplified. It's just a fancy way of saying that either there are never any triangular objects, or never any square objects, or never any pentagonal objects, or never any circular objects, and so on and so on. The trouble with that translation, though, would be that we'd have to have an infinitely long list, and we'd never actually be able to complete the translation. If you could go on for every particular sort of shaped object and say that either it didn't exist, or the next one didn't exist, or the next one didn't exist, and keep on going forever, it would be equivalent to the original statement that there are shapes that are never exemplified. Unfortunately, for the nominalist, human beings are finite, and any translation we produce would have to be finitely long. The nominalist might come back, though, and say that we could just add 3 dots at the end. 3 dots meaning, and you keep on going in the same fashion ad infinitum. For example, when you have a mathematical series like 2, 4, 6, dot, 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 you're told, you're basically implying that the next element in the series, which would be 8, of course, follows according to a certain rule of expansion of that series. In the case of the 2, 4, 6 series, we know the next element is 8, and the next element after that is 10, and 12, and 14, dot, dot, dot. You just keep on going. You'll have to know, though, what the rule of expansion is, and you have to be able to state that rule of expansion in an adequate way. In the case of the 2, 4, 6 series, the rule of expansion is obviously +2. So we can state that rule. We can say 2, 4, 6, 8, dot, 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 and understand how to expand that series indefinitely. So what would the rule of expansion be for the series that either there are never any triangular objects, or never any square objects, or never any pentagonal objects, or dot, dot, dot? What's the rule of expansion that would enable us to interpret that series as expanding outward infinitely without actually having to write out or even conceptualize each term in that series? Because clearly the translation that either there are never any triangular objects, or never any square objects, or never any pentagonal objects, or dot, 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 in itself is something that's finite. I've just stated it. It includes several phrases and then the three dots, and that whole thing is a finite statement. So if we can define what the three dots stand for there, that is, we can define the rule of expansion for that series, then it seems it will have a good nominalistic translation of the original statement. When you try to figure out how to state that rule of expansion, though, it seems that you're going to be stuck with some reference to abstract universals, which would mean that the nominalist translation, even though finitely statable, would not enable us to avoid reference to abstract universals in translating that original statement, that there are shapes that are never exemplified. Well, what would the rule be? The rule seems to be keep on going until you've covered every possible kind of shaped object. But it's pretty clear that talking about possible kinds of shaped objects just gets us back to talking pretty evidently about abstract universals. What after all is a possible kind of shaped object, especially when you're talking about possible kinds of shaped objects that never actually exist? What could that be except for a shape or abstract universal? So in the end, it's not obvious how the nominalists can come up with a adequate nominalistic translation of our original problem statement, that there are shapes that are never exemplified. So, summing this up then, the realists can argue that there appear to be truths about abstract universals which resist any attempt to translate them into equivalent statements that are wholly about concrete particulars, and for that reason, on the face of it, there appear to be abstract universals. Until the nominalists can come up with an adequate nominalistic translation showing that these statements, after all, can be rephrased into logically equivalent statements about concrete particulars, the realist about abstract universals seems to have the edge in the argument. It may be that with sufficient ingenuity, the nominalist can come up with a translation. But until he does, the realist has got the edge.